Well, first of all, I'd like to say thank you so much to the organizers, both Marta and Marcin and the rest of their team. We're really happy to be here and look forward to a great collaboration. So, also thank you for the introduction. As noted, I think in the title, this is a rough translation. My title of my talk is Who's Learning to Code? I'm the director of the Simula School of Research and Innovation, and we actually will start out with a little bit of an introduction about Simula just so you can understand where we're coming from and why we want to be involved with initiatives which teach high school students notably to code, but also to use tools like e-learning and et cetera. So Simula is a nonprofit research institution which is organized as a corporation and is owned 100% by the Norwegian Ministry of Education and Research. And don't mind too much this structure here. You can see it's like a company, but we are, I assert, a basic research institution. And we are an ICT, or an Information and Communications Technology firm. We do research in communication systems, software engineering, and scientific computing, which all sound pretty far out there perhaps, but I think that it's important to note here that we are different from Norwegian universities. Why are we different? Well, for one start, it's very easy or easier for us to participate in very interesting and cool projects like this one. I'd say in general, we enjoy a greater focus on research. These results are exploited to a higher degree. There is focus of projects and we can commercialize those more easily. And we also have a different model of employment. We actually are focused very much on educating master students and PhDs, and when we find someone good, we can snatch them up without too much bureaucracy. So in a sense, we enjoy more agility. And last comment on that, as you see, also we have employees from Poland, all across Europe, North and South America, and Asia. So we are very proud of our diversity, and we think that that's a big strength in recruiting talented people globally. So that was really the end of my introduction of Simula as an institution. I'd be happy to take questions about that later. But to the point, we're very interested in creating a firm basis along the entire educational pipeline. We want to be able to encourage the development of important skills that later might lead to us to be able to recruit the right people. So the whole educational pipeline is represented here. And in the context of this project, it is my hope that, and you can see right here, that we have a building at Fornebu and another one. So this is kind of, it looks like space in Oslo where we are. But we hope that we can be the glue and help to bring some of the experiences in our community to Poland in this collaboration. So, why learn to code? Vast computer systems now underline most of the modern world. Some of the other speakers have touched upon this, but I don't think it can be overemphasized how dependent we are currently on software systems, both hardware, integrated and not. So for instance, it's very easy to see that. Some of these are very visible. In this case, we can see multimedia presentations. Of course, I don't think any of us have not seen a movie in the last few years that doesn't incorporate CGI elements, of course, but there's games we play, our children play those games, we use all different types of apps. And of course, security is a big issue. We all have mobile phones, for better or for worse. But I would also like to assert that it's everywhere, but they're not always visible. So what you see here is an underwater control system for offshore drilling. And although it's not very highly publicized, failures in these systems cause actually billions of dollars in damage and severe environmental harm, like the Deepwater Horizon event that happened in, excuse me, in 2012. Here we can see some networking cables. So probably this is something that we don't think about too often, but every time you miss a train or there's a problem in the local transportation systems, very often it's due not just to hardware failure, but to software issues. People's lives are disturbed, it causes billions of dollars in damage. And really, the problem is that we're not all too aware of how those systems work and how they can fail. A kind of personal example, because my background is in biomedical research, is that now in healthcare, there are a lot of novel research techniques. This is a human torso shown from about the waist area to the shoulders, and we see a 3D model of it. So this is an example of medical research, and that's great. But also, all of the medical imaging and health systems, and even to the degree that we might make a doctor's appointment that is completely dependent on software. So these are mission critical systems, I would say. So I think we're in a new age. Standard education has to encourage literacy in programming. So the rest of this talk is just gonna focus on really why learn to code. What are the other reasons, as I've already given you a couple good ones. And who is doing this? Who's teaching our children or ourselves to code? Who are the front runners in these efforts? And finally, I'll give you some ideas of how some of these concepts are being practically implemented in classrooms, especially with regard to what is happening in Oslo and in Norway. So, what is coding good for? Obviously, it's good to make software, but what else can it be useful for as a reference point? Well, because everything, as I've outlined, is so based on that, learning about code and basic structures of programs can give you basic insight into how systems work, technology systems. It can inform your daily life. It can inform your understanding of policy. It can form our understanding of priorities for the future. So in a sense, it can underscore basic academic knowledge we have in other areas at this point. This is a badge showing someone with a job. And I think many countries in the industrialized world in the last 30 years have experienced a lot of loss of employment, but there's a new sector emerging, and that is actually the software sector. So teaching our children can code can make them more competitive globally in a very large way. Here's a point about code that was also brought up earlier. It's not just about sciences. We're learning about how to teach students science and mathematics via coding, but it's also a very human problem. Although there are systems that are automated, right now, code is conceptualized by humans. It requires understanding at a human level, and really that means participation from everybody. So the analogy I've been building up here is that for really thousands of years, until very recently, the Age of Enlightenment, reading, literacy, and writing, those were things that were the domain of the very few, the very privileged. And there was almost a priesthood, right? So the wealthy and the people that worked for them and monks could read and write. But then it became acknowledged, okay, that this is a good idea for everybody to learn, because really we share knowledge that way. And I would like to say that I think in the same way, it is a responsibility now in the future to teach people the secrets of coding that are really not so secret. We don't need a priesthood necessarily. We can all participate in this new type of knowledge. So who is leading this trend? I'm gonna get to this point. Actually, this is an example from the United States, and I'm just gonna show a brief YouTube video on this. Alt-tab, yeah. Thank you.
Tic-tac-toe. I think it was pretty humble beginnings. I think the first program I wrote asked things like, what's your favorite color? Or how old are you?
I first learned how to make a green circle and a red square appear on the screen.
The first time I actually had something come up and say, hello world, and I made a computer do that. It was just astonishing.
Learning how to program didn't start off as wanting to learn all of computer science or trying to master this discipline or anything like that. It just started off because I wanted to do this one simple thing. I wanted to make something that was fun for myself and my sisters, and I wrote this little program and basically just to add a little bit to it. And then when I needed to learn something new, I looked it up either in a book or on the internet and then added a little bit to it.
It's really not unlike kind of playing an instrument or something, or playing a sport. it starts out being very intimidating, but you kind of get the hang of it over time.
Coding is something that can be learned, and I know it can be intimidating. A lot of things are intimidating, but what isn't?
A lot of the coding that people do is actually fairly simple. It's more about the process of breaking down problems than sort of coming up with complicated algorithms as people traditionally think about it.
You don't have to be a genius to know how to code. You need to be determined.
Addition, subtraction, that's about it.
You should probably know your multiplication tables.
You don't have to be a genius to code. Do you have to be a genius to read?
Even if you want to become a race car driver or play baseball, or build a house, all of these things have been turned upside down by software.
What it is, computers are everywhere. You want to work in agriculture? Do you want to work in entertainment? Do you want to work in manufacturing? It's just all over.
Thank you, Martine. So you get the picture, and the link is down there if you'd like to view the rest of that later. But generally, the consensus is that if Bill Gates tells you to do something with computers, you should do it. Of course, I'm joking, but we can see here Angela Bassett, there's Ashton Kutcher, Shakira has learned how to code, then we see Mark Zuckerberg. So the idea here is that anybody can learn, and things are moving from the domain of specialists into something that is really tenable or achievable for most of us. I don't want to suggest that that's just happening in the States. At the top level, the Digital Agenda for Europe has set several priorities, including this Pillar 6, which is enhancing digital literacy skills and inclusion, which also includes some of these capacity building projects. Something really cool and notable that you might want to check out for next year is the European Code Week. Last year it was October 11th to 14th, or I'm sorry, 15th. And as you can see, there were events all across Europe. You can look at where the events were in Poland. Perhaps some of you here already knew about that or were involved, but these are a community bottom-up based event where you can get together with different teachers or perhaps in your community and really do things from really the maybe primary school level all the way up to adult levels. So that was very successful, and it's nice to see communities really getting together and working on these things. In a conversation about leading trends, we cannot avoid talking about the UK. At least in the English-speaking world, and I think globally, they're really a leader in making some top-down political decisions about what's going to happen in the classroom. As of September 1st of last year, they implemented a brand new curriculum for computer literacy, and that includes for the first form, and that means children that are 5 to 7 years of age. It included a list of achievements which included understanding the concept of algorithms and being able to code and debug simple programs. So this is a very high order. There's a lot of challenges associated with that, of course, especially in a society that's just doing it for the first time. Luckily, there's actually a lot of tools that are being developed, and not all of them would be so hard to translate language-wise or practically-wise into different environments. So here's an example of coding push with bite-sized TV shows. So infotainment and classical tools that you can actually use in the classroom. This is also really another great example for people that already have a bit of competence. The YRS, or Young Rewired State, was started by a lady called Emma Milquini about 10 years ago, and this is a global community of digital makers, people that code and make different things, 18 and under. So really, a lot of them are teenagers, and what they do is organize independent events in different countries. They share code, they share ideas, so it's a community where they can build upon itself, and it has a social function as well as a learning-based function. And I believe that a nice way to check out what they're doing there is to look at their YouTube site, YRS Everywhere. It's predominantly in the UK, but has since spread to different countries. I was not able to find any group in Poland, but maybe next year there will be. We'll see. So, moving on to how some of these ideas are used in the classroom. And I'm going to focus here on Norway because that's where our practical experience comes from. HOGS is the Hundsund Ungdomsskole. So it is a local, technology-focused middle school. So the students are around 12 to approximately 15 or 16 years of age. And it's in the local comuna where Simula is. They, in fact, right here on this web print, you can see that the 4th of February, so Wednesday, is Girls for Science Day. So they focus a lot on technology dissemination and novel techniques. And I was talking a little bit earlier in a meeting about the flipped classroom concept. So actually, they're very proud of being this technology school. And they exercise the flipped classroom, which is an example of e-learning. But they also have been involved in a lot of different initiatives to include digital readiness. And although none of us appear in this picture, we actually are involved in a takeout of this picture. And what that says is digital readiness gives a unique collaboration between students and the business world. And in this case, they're learning Scrum technology, which is a software design implementation technology. So this is a nice example of how something that's been very important in the technological world and relates to coding and coding methodologies is useful in a completely different discipline. So just an example of some technology transfer that doesn't necessarily have to do with technological study. This is a school we've also been involved with very closely. This is Sandvika Videregående Skole, so that's more like high school. And they are a modern school, as you see here. They indicate that they're modern, and they're known for academic excellence, but don't have the same technological focus. So the question might be in your minds, that's great, Molly, but my school doesn't have the types of resources in terms of technology in order to implement some of these ideas. Well, Sandvika is very similar. The students don't all have laptops. They're more traditional school, but they were open to collaboration. And last year, a year ago spring, we had an after-school program where they actually learned to implement Python code to solve a very simple problem. Who falls faster? What if you're skydiving or you're base jumping? Or maybe it was bungee jumping. Any case, they eventually found out the answer, but it created a lot of interest, and they learned from the bottom up how to program and how to implement a physics problem. This is a very traditional school with very few resources in Eastern Oslo, and we were recently involved in a project there to implement some courses during what they call their research weeks. So they have a program where they teach people how to actually conduct research. It's sort of a research readiness concept. And in this case, we used Arduino. And this is a nice tool too, so I mention it, because it's actually like a tiny computer, and you get a starter pack. Perhaps also some of you have heard of this. And in this case, they were working with optical fibers and programming the Arduino to use the optical fibers to measure the transmission of light through a liquid that was a mixture of milk and water. And eventually they measured everything and had to come up with some novel answers. We've had, and this is the last school example, Bjørnegård Skole is also a middle school, so 13 to 16 years of age. We've had a very tight collaboration with them. And I think another interesting aspect of this is that in order to really create change within the school system, what you need is the willingness from the schools. And that's so great to see everybody here. We ended up having a great collaboration with Bjørnegård because the administration and teachers at that school were extremely open to the idea that we could come in and help teach some skills. And what's happening right now is actually that my colleague, Jonas, is currently teaching a programming course for the 9th class. So they would be 14 years old, and that is early morning, twice a week, running now from the beginning of January until February 12th, and they are learning, again, Python. And so those of you that are at the workshop will get to see a little taste of that. And there we can see Jonas in action and the casual attitude of the Norwegian students as they sit on the desk. And one of the nicest things about this, I've understood, is that there's a curriculum, obviously, that was developed and implemented by Jonas and our other colleague, Emil. But the hardest part has been getting the students to stay within the curriculum. So many of them are not that interested in actually following what we say because they take an idea and are immediately asking other questions, asking how to implement such and such, asking how they can make their idea that might be a computer program they saw, or it might be a quiz to amuse their friends. They want to implement that instead. So there's real enthusiasm. There's about 30 students, and a third of them are girls, which is also encouraging. So there's challenges in transitioning to a new paradigm whenever you do that. And I think that coding in itself is scary. I'm going to use the analogy that it's like math. And that's someone being terrified of math, of course. Maybe I won't find so many in this school, but you know, there's people where they would ask me what I did, and I said, oh, I'm do applied mathematics and engineering, and they're like, I hate that. So there's definitely some fear out there. And I think that there's also this idea that coding is a very aggressive culture. There's maybe people have been hearing about things in Silicon Valley, or it's extremely competitive, it's a race. And I would make the analogy to the typical tech interview or tech culture as very competitive. Maybe you might be feeling like you're examined, or you're asked random questions, or you're working on brain teasers. And none of those things and that culture doesn't really give a good idea of who's going to be good at coding and how to find out who these people are. So essentially what I'm saying is that there needs to be a cultural change, and that involves us educating ourselves as well. Luckily, there's a lot of resources in order to help make this change happen. This is an example of Cold Club. So as you see, this is an after-school program, not that different from what we're currently implementing, but younger children and easier tasks in children 9 to 11. And also there are some here at Code for Life, this is also UK, there's some government-funded development to create tools that can be used in the classroom in order to implement the new political changes in that country. So I would encourage you to take a look there, and some of them can be very useful. So I'm just going to mention now a couple of resources that are available for people that are interested in teaching their students but think that they first need to get some competence themselves. I certainly could be a better programmer, but the good news is there's tons of resources out there for everybody now. So this Flatiron School is maybe a bit more ambitious. They offer a 12-week program. It's in New York City, and they say when you're done, you can be actually ready for an entry-level position at a software engineering firm anywhere in the world. Hacker School is also similarly refined, and also in London, there's a similar program called the General Assembly, where you can learn to code in short weeks. But for those of us that are already gainfully employed and may not have time for 12 weeks, there is this man with 26 million students. He's a young guy who started the Code Academy, and he was recently invited to the IMF, the WEF in Davos, where they were asking him about the future of the job market and the future of the economy. And he actually started this online in 2011 and steadily gained users because he wanted help, and he couldn't find help that was low level enough. So this is a great place to check out, and there's other initiatives like that. People, anybody from the age of 6 or 7 all the way until you can't learn anymore can learn to code interactively for free at a site like this. And with that, I'd like to close just with the words that teaching kids to code and teaching ourselves to code is a responsibility in literacy, and it's preparing ourselves for the future and whatever that may bring. It is really challenging, but luckily there's lots of tools, and we're gathering experiences together to try to tackle these challenges. Thank you.
Dziękujemy bardzo za to wystąpienie.